Hey guys, Mr. Backberg here. In this video, we're going to take a look at some applications. So in this example, we're going to be locating a fire. Forest Ranger Adam at Ranger Station A sights a fire in the direction of 32 degrees east of north, and Ranger Bob, who is at Ranger Station B, which is 10 miles due east of Station A, sights the same fire on a line of 48 degrees west of north. And we want to figure out how far each ranger station is away from the fire. So the first thing we're going to do is draw a picture of this to model it. So I'm going to start with Ranger Station A right here. And it says that the fire is 32 degrees east of north. So due north would be straight up, but we are 32 degrees east of that. So this is a 32 degree angle in here, and this is where the fire is located. And our other ranger station happens to be 10 miles due east, which means straight to the right, and that's going to be Ranger Station B, and we're told that from due north, we're 48 degrees west, so it's going to be 48 degrees left here. So this is a 48 degree angle in here, and this distance straight over from A to B is a distance of 10 miles. Now in the corner here, this would form a 90 degree angle. Since we've got this 32 degree angle on the outside, that means the angle on the inside is a 58 degree angle. And similar things on the right hand side. This would form a 90 degree angle, so the angle on the inside is 42 degrees. Now that we've got those two angles, that means this angle up here, if we want our angles to add up to 180 degrees, is going to have to be an 80 degree angle. So now what we're missing is this side A over here, which is from point B over to the fire, and we're also missing side B over here, which is from point A up to the fire. So let's start by finding the length of side A over here. So I'm going to do A over the sine of our 58 degree angle equals that 10 that we've got over the sine of the 80 degree angle. Now I'm going to have to multiply that sine of 58 over to the right hand side. So A is going to equal 10 times the sine of 58 divided by the sine of 80. And I'm going to type this into my calculator. And we should end up getting about 8.6 miles as that distance. So I'm going to label that in here. This is 8.6 miles. Now we still need to find side B over here. So I would do B over the sine of 42 equals 10 over the sine of 80. Multiplying that sine of 42 over to the right-hand side, we're going to get B equals 10 times the sine of 42 divided by the sine of 80. And again, I'm going to type this into my calculator. And when we do that, we should get about 6.8 miles. So this distance in here is about 6.8 miles. In this example, we're going to look at finding the height of a telephone pole. So we've got a road that slopes 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees, and the pole casts a 14.5-foot shadow downhill along the road. We want to figure out what the height of the telephone pole is. Now the first thing we want to do is try to sketch out a picture to represent this problem. So here's our flat horizontal line, and it says the slope of the road going up is 10 degrees. So this is a 10 degree angle in here. And we've got our telephone pole coming out of the ground, and it's going straight up. Now it says as the sun is hitting this telephone pole, it casts a shadow on the ground, which is 14.5 feet long. And it also says the angle of elevation up to the sun is a 62 degree angle. So let's say the sun is up here somewhere, coming down, forming a 62 degree angle of elevation in here. And since that's 62 degrees as we work our way down to the ground where this hits the shadow, this entire angle in here is a 62 degree angle. But since we know that this little angle on the bottom is only 10 degrees, then this little piece up here on the top would only be a 52 degree angle, and we're going to try to find the height of this pole. So as we start setting up our law of sines, this height of the pole is opposite of that 52 degree angle. So I'm going to go x over the sine of 52 equals, now the side length that we've got is this 14.5 going across the bottom. So I'm going to put 14.5 up here. Now it's going to be helpful for us to know the measure of this angle on the top of our triangle right here. So here's what I'm going to do. I'm going to extend this horizontal line over to the left here. And then if we remember some properties of geometry, This angle on the right with the 62 degrees and this angle over here, those are vertical angles, meaning that they're congruent to each other. So this is also a 62 degree angle. And then this in here would actually form a 90 degree angle. So if I take 90 minus that 62 degrees, then this angle in here is a 28 degree angle. So this is going to be over the sine of 28 degrees. Now I'm going to multiply that sine of 52 over to the right-hand side. So x equals 14.5 times the sine of 52. And then we have to divide that by the sine of 28. Now I'm going to type all of that into my calculator. And when we do, we should get a height of about 24.3 feet. So this telephone pole is a little bit more than 24 feet tall. That's going to be it for this video. Thanks for watching.